characteristics of an exponential relation. So before we looked at the characteristic of a quadratic, and we looked at quadratic, there was a vertex, there was the x-intercept, there's the y-intercept, all of these things, right? So now we're going to look at the same thing, but with exponential. So the general form of an exponential relation is, we looked at that, it's y equals a b to the power of x. And remember that sometimes you just see y equals b to the power of x just because your a is 1. Okay? A represents your initial value. A represents what you're starting with. If your initial value is 1, you're starting with 1, I don't usually write it as 1 b to the power of x. I usually just write it as b to the power of x. Okay? So this is why sometimes you don't see that a value. Okay? It's still 1 though. Where a is the initial value, so write that down. And b is called, it's the base, but it has a special name for it. It's called exponential. It's called a growth factor or a decay factor. Okay? So let's write these words. So growth or decay, so either or factor. Okay? So I have two different equations here. I have y equals 2 to the power of x, and I have y equals 0.5 to the power of x. If you're looking at both of these equations, and you're looking at their graph, what's the difference between their graphs? Which one's increasing? The base 2. And the one that's decreasing is the base 0.5. So the base makes the difference. The base is the one that tells you if it's increasing or decreasing. The base is the one that tells you if you have an exponential growth or if you have an exponential decay. So if your base is greater than 1, as long as it's greater than 1, then you have an exponential growth. So 1.5, 1.05, 1.3, 3, 7, you have an exponential growth. Once your base is between 0 and 1, 0.25, 0.5, 0.1, 0.8, anything that's 0 point, that's called an exponential decay. Okay? So, if b is greater than 1, then the relation is exponential growth. And if b is between 0 and 1, then we have exponential decay. Okay? Growth, guys, if you're moving from the left to the right, always moving from the left to the right. If I'm putting my hand on the graph and I'm moving from left to right, I see that I'm going up. I know it's growth. If I'm going from left to right and I see I'm putting my graph and then I see it going down, that's a decay. Okay? So you see this? Whoop. Right? While this is whoop.
Does that ever go into the negatives?
What is it?
Does the line ever go into the negatives?
Unless you have transformations. No, it does not. So in our cases, probably it will not. Okay, so what he's saying is, would it ever go like this? Or would it ever go like this, right? In our cases, we don't do that because we're not dealing with transformations of exponential, but it does. In regular, in like U-level courses, we don't have these cases. Okay? All right. see here? What do you see on the end of the graphs? You see that it's getting near that x-axis, but it's never reaching that x-axis. If I actually zoom in, you'll see that this line here will approach the x-axis, but will never touch it. It will be like 0.00001 or 0.0000005. It will be a number that's very small, but it will never be a zero. Okay? On your calculator, divide 1 divided by 235.
0.0042557319.
That's 1 divided by 243, 2 whatever, the number I...
Yeah, that's what I got too.
Okay, so because you have the 10 times 10 into the bottom. Right? So you see that when you divide by a big number, you're going to get 0.0000 number, right? If you got 4.23 times 10 to the power of negative 3, that's the negative 3 is replacing how many zeros you have. Okay? So what I'm trying to say is it will get close to it, but it will never be a zero, no matter what number you try to plug in. All right. So as I told you earlier that B is considered growth factor, we wrote up there, and we wrote that B is considered decay factor if it's between 0 and 1. Are we okay with that? So since that graph is going to get close to the x-axis but never reach it, are you going to have any x-intercepts? No. You're never going to have an x-intercept. Okay? Again, unless we do transformation, then we will have, but we're not going to touch that. Okay? So in this case, what will the x-intercept be? There's no x-intercept. Because my graph, so if this is my thing, right? And then if it's if it's decreasing or if it's increasing, what am I looking for? If it's decreasing, okay, so we're going to see this, as you guys can see, it's going to be kind of like getting close to that line, but it's never going to touch it, so I have no x-intercept. And even if I have something that's going up, so I have this, you're going to see that it's going to be kind of close to that x-axis, but it's never going to reach it. Okay? So y is never going to equal to 0. Y is going to be 0.000000 something. Okay? If you're looking at both of these graphs that we have up here, what's your y-intercept? 1. So I'm going to just zoom in a little bit. So if you look here, your y-intercept is right here and right here. And both of them have a y-intercept of 1. Right? The y value is 1. Now that's your initial. Remember I told you, if there is no number in front of the base, that's going to be a 1. If there is no number in front of the base, that's going to be 1. That's your initial. Okay? If you're starting with 10, where do you think that y-intercept is going to be? At 10. If that's your starting point, if that's how much you started at day 0. Does that make sense to you? All right. So in this case, to find the y-intercept, plug in 0 for x. Okay, eyes on me for a second. I have y equals 2 to the power of x. If I put 0 here, what's 2 to the power of 0? How about if I have this? Y equals 0.5 to the power of x. I'm going to replace x with a 0. What's 0.5 to the power of 0? 1. And that's why your y-intercept is 1. Okay, because anything to the power of 0 is 1. Any questions about this? So use the table of value to answer the following question. So they give you x and y, right? So the first column is the x, the second column is the y. They're asking you to find the first ratio. What do you do to find the first ratio? y2 divided by y1. Excellent. So y2 divided by y1. So I'm going to start from the 3 and divide by 1. What's 3 divided by 1? 3. Then 9 divided by 3. 27 divided by 9. 81 divided by 27. Good. So you found the x-intercept. Tell me about it. So is the relation exponential? And why is that? Perfect. So can you write that? What's your initial here? What's your initial? 1. Look here, eyes on me. Your initial is always going to happen when x is equal to 0. Okay? So at x equal to 0, I'm starting with 1. Right? So this right here is my initial value. I need to know what my initial value is. Now to write an equation, and I know it's an exponential equation. What is my exponential equation?
Y equals a bracket h exponent x.
B to the power of x, yeah? Oh. Now what do I replace them with? Tell me, what do I replace A with? 1. What do I replace B with? 3, because that's my ratio. Okay? That's my growth factor. So that's going to be y equals 1, 3 to the power of x. Do I need to write that one?
No.
So can I write it as y equals 3 to the power of x, just to make things simpler? Yes. Now if it's anything other than 1, if it's like 5 or 10 or 3 or 7 or whatever it is, you have to write it. You can't just ignore it. So to graph this, I'm going to have to pick a scale because I'm going all the way up to 81, so I might want to pick a scale of 10 maybe. Right? You might not be able to pick all the points, but you don't want to have a very small scale at the same time. Okay? So I would say, let's do going up by 10. So you see when I'm picking my scale, I have to stick with it. If I started at 10, I have to keep going up by 10. And then my x scale is going to go up by 1. 0, 1, so my point is gonna be very, very close to the origin. Then 1, 3. You guys know where I'm getting these numbers from, right? So if you look at the table, 0, 1, 1, 3, what's 2? 2, 9. Okay? So 2, 9 is close to the 10. 3, what was 3? 27. What's 4? Okay? So you see this jump in.
Where's the last part?
Are we okay with this?
Yes.
Does it look exponential to you? Perfect. If it doesn't, that means you've made some big silly mistakes that you have to go and look at, right? All right. So, here's your question. And how are we gonna group you? I don't want the same groups.